Hi everyone, welcome to Spentarn Learning Platform, and from today we will be starting the practical part of this series of data analysis with Power BI. First of all, when we are performing data analysis, so let's just think about it that what is the most basic thing that we need to perform data analysis? To perform data analysis, the first and the most basic thing that we need is the data itself, correct? So, where are we going to get this data from? The one that is needed for analysis purposes. Obviously, Power BI is not going to generate the data or it is not going to have the data in itself from the beginning only. No. See, different organizations do what? They store their data in different, resources. Like some organizations might choose to store their data in an SQL Server database, which is installed in an on-premises data center. Other organizations might choose to use the same SQL Server database, but it might be installed on some kind of cloud, maybe Azure. Okay. Then some organizations might choose to store the data in, let us say, Access databases. Someone might choose to store it in, let us say, Snowflake. Someone else might choose to store that data somewhere else in some other kind of data store. Someone will be storing it in SAP as well, SAP. Okay. So no matter where our data is stored, for analyzing it, what do we need to do? We need to bring it into the Power BI environment. So how do we do it? We are going to have a look at that now. So this is Power BI desktop that I have opened here. Okay. And in here, in Power BI desktop, I hope all of you can see that on the left hand side of this window, we are having four buttons. The first button here, it is for the report view. In Power BI desktop, we are having four different kind of views. The first one is a report view. The second one is table view, okay, or the data view as well. The third button is for going to, the model view. And the fourth button over here, it is for the DAX editor, DAX query editor. Now we will be having a look at all of these views one by one as and when it is required. But let me tell you right now that as soon as Power BI desktop opens, the window that we are in, it is showing us this particular canvas, okay, where we are going to put our visuals. Apart from that, we can see a filters pane here. We can see a visualization pane where a lot of inbuilt visuals like bar chart, column chart, pie, donut, scatter chart, all of them are available. And we can see a data pane here as well, which is empty right now because we have not loaded any data to the Power BI desktop environment. Okay, and there are some menu options on the top, okay, where we see different types of tools. This particular window that opens in front of us by default as soon as we open Power BI, this window is the report view window. So the report view opens in front of us by default as soon as we open Power BI desktop. Here we have the table view. I went to the table view. It is empty as of now because we have not loaded any data here yet. Once we load the data here, we will be able to view that data in this space. And in the model view, we will be creating our data models. Now, in Power BI, as I said earlier, that initially we do not have any data and we need to connect with our different data sources and get the data from them. So how do we do that? So for that part, see, we have something called connectors in Power BI. Okay. Now, what are connectors? So connectors are nothing but basically, APIs we can say, which are used to connect to different data sources and extract the data from them. Okay. Which are used to connect with different data sources and extract the data from them. All right. Now, in Power BI, we are having hundreds of connectors to connect with many different data sources and extract the data from them. Okay, now how can we see these connectors? So in here, I hope all of you can see in the Power BI desktop window, we have in the home menu, we have the home menu on the top. Inside the home menu, we have this data section. And in here, see, there is this get data button. I hope everyone can see this. Now the get data button, if you look at it carefully, you can see that it is a clickable button with two parts in it. Either we can click, this icon of the get data button, or we can click on this drop down. So if I'm clicking the icon of the get data button, then a dialog box appears in front of us. In the dialog box, we are in the all section now. So here we are getting a list of all of the connectors which are available in Power BI. And if I keep on scrolling down, you will see that we are having hundreds of connectors available here. Okay, so we are having these connectors for every different type of data source that we can think of. So we are having connectors for Excel workbooks, which means that if our data is stored in some kind of Excel workbook, okay, and we want to extract it from there, then we can use this connector, the Excel workbook connector for that, okay, to connect with our Excel workbooks. We have connectors for text CSV files, XML files, JSON folder, PDF, Parquet files for SharePoint folders as well. Then we have connectors for these different types of databases like SQL Server databases there, Access databases there. There is MySQL database, there is SAP HANA, okay, there is Oracle database and many more. Amazon Redshift is also there and many more. Okay. Then after that, we are having connectors for some of the Microsoft Fabric resources like these warehouses, lakehouses, data marts, etc. Obviously, we are having connectors for, Azure-based services, which are also Microsoft products. Okay, Dynamics 365 and so on, Salesforce and so on, and many other resources as well. Okay, so we are having connectors here for different types of data sources from which we want to extract the data. Now, what is the generalized purpose of extracting the data from different data sources? So see, the method, generalized method, I'm giving it over here. First of all, see, we have to, we need to know that where is our data located, which we want to, extract so that we can perform analysis. Now, wherever our data is located, either in an SQL server, in an on-premises, some kind of on-premises files, in Access database, Oracle database, or anywhere else, wherever the data is stored, first of all, we need to, choose the connector for the type of data source that we want to extract the data from. Then, after that, we need to provide the location of the data inside that data source, that where is the data located. As I have written over here that, the method to provide the location of the data might vary with different connectors, and I'm going to show it to you. Then after that, we need to fulfill the authentication requirements as well, because Power BI needs to confirm if we are actually allowed to access the data from that source or not to prevent unauthorized access. And once all of these three things are done, then we have to, select the data that we want to extract from the source. Okay, so this is a generalized method to connect with the data from different data sources. And let me show you an example. So on my system over here, the laptop that I'm using for this particular training, on this laptop only, I have a local copy of SQL Server installed. Let me just show it to you. It's loading. All right. We have databases here. See, I'm having a server. I hope all of you can see it. I have this SQL Server locally installed on my system. Inside the server, if I go to databases section, then inside databases, I have a database called AdventureWorks DW 2020, which has a lot of, tables installed in it. Okay. So these are the tables from which we want to get the data. Basically, this is the database from which we want to get the data. And this database is installed where? It is installed in the local server on my system. So because this is an SQL Server database, so I will go to Power BI Desktop. And in here, I will choose a connector also for the SQL Server database only, this one. So this is the first step, as I was saying, that first of all, we need to choose a connector for the type of data source from which we want to extract the data. Okay, I click on connect. But think about it. I have just told Power BI that I want to extract the data from an SQL server, some SQL server. Which one? Now there might be hundreds of thousands of SQL servers installed all across the globe, correct? Because a lot of people use them. So which specific SQL server do we want to connect with? So we will need to provide the address of the SQL server which we want to connect with. Now, because the SQL server that I want to use, it is installed locally on my system only, the same laptop on which I'm using Power BI Desktop. So that is why for the server name, for the server address, I will simply provide a local host here. Okay. Then in this case, we can also provide the database name, but that is optional. So I'm going to leave that. And then there is something called data connectivity mode here. The default option here is import. We are going to leave it at that. What is connectivity mode? We are going to learn that in a few minutes. Okay, but just remember that we are, keeping it at the default choice here. That is import. So I click OK here. I'm going to connect with the local host. Okay, just a second before I do that. Okay, so because I already connected with this server, so its credentials were saved, I need to show you the process of providing the credentials as well. Okay, so as I was saying, first of all, we choose the connector. And in the next step, see, when I'm providing the address of the server, that which one we want to connect with. So basically, this is the second step. We are providing the location of our data, that where it is stored. Okay, now the method to provide the location here is that this pop-up window opens where we have to provide the name of the server. Okay, I click on OK here. And see, in the next step, it is asking me for the credentials to prevent any kind of unauthorized access. Okay, so because I'm using the server which is installed on my system only, so that is why I'm going to use the Windows credentials, the current credentials only. We can provide database credentials or Microsoft account credentials as well, if that is supported. Once that is done, see, the next step is we need to select the data that we want to extract. So as I showed it to you earlier, that in this particular server, I am having 4 databases installed, and Power BI has connected to the same 4 databases over here. We need to choose from which one we want to extract the data. So I say AdventureWorks, I expand that. A list of all the tables, views, and stored procedures. Not stored procedures, sorry, table valued functions, TVFs. We have got it here. Okay, I'm going to pick up only the tables right now. So there is a table here called fact reseller sales, this one. I want to extract the data from it. See, if I just click on any of the data, any of the tables, I'm not checking the box in front of it, then what is it showing here on the right hand side of the screen? It is showing me a preview of the data in that particular table. Okay, but if I check the box in front of any table, then also it shows me a preview, but checking the box also means that this is the table from which I want to extract the data. I have selected that. Okay, so I am selecting the fact reseller sales table. Now I hope that all of you are familiar with the fact, if not all, then many of you will be familiar with this thing, that inside the SQL Server databases, the tables are all connected with each other through relationships. If not, then I can show it to you here as well in the AdventureWorks database. These are all of the tables. All right. So see, these are all of the tables that are there in the database, and you can see that the tables are connected with each other through these relationships, which are displayed here. Correct? So somewhere we have the fact reseller sales table as well here. Okay, let's not spend a lot of time in trying to find it. It is available somewhere here. But anyways, I hope all of you can guess that the factory seller sales table, yeah, here it is. See, this table is also connected with some other tables through the relationships. Now, which tables it is connected with, we're not going to go into that. But in the data source, that is in the SQL Server database from which we are picking up this table, in the data source, this table is connected with some other tables through the relationships, right? So in here, we are having an option, select related tables. See, right now we have clicked on just the factory seller sales table. We have selected that one only. But as soon as we click on this button, select related tables, what happens is that all the other tables with which the factory seller sales table is having a relationship in the data source, they also get selected here automatically. Okay, so this is being picked up from the data source only, that with which other tables factory seller sales is connected. Okay, with which other tables factory seller sales is connected, and those tables are picked up automatically. But this doesn't mean that this choice is fixed. Okay, we can still edit it. Like the dim date table that has been selected here, I do not want it. The dim promotion table, I do not want this as well. And if you want any other table, then we can select that. It is possible. Okay, so right now 5 tables are selected. Now we have 3 options here: load, transform data, and cancel. Now, if I want to load this data from these selected tables, 5 of them, as it is without making any changes to it, then we can go for the load option. If we want to clean and transform this data first before loading it to Power BI, then we can go to the transform data option. And cancel, I believe everyone can understand this. This is going to cancel the entire process of loading the data. For now, I'm going to load. So you can see that the data from these 5 tables, it is getting extracted. And now we can see these 5 tables here on the right hand side of the screen in the data pane. These 5 tables are available here. And if we extract them, then we can see the columns inside them as well. What columns do they have? We can see that as well. All right. Now, remember that when we were extracting the data here, then at that time, when we selected the connector for SQL Server database, then at that time, the connectivity mode that was chosen was import. That was the default choice. So that is why when we hover our mouse over any of these tables, you can see that the storage mode here is selected as import. For dim product also, you can see it is import. For dim reseller also, for sales territory, and for factory seller sales also, it is import. And if we go into the table view, then we can see the data inside these tables over here. So we extracted this data from one source. Okay, but it is possible in Power BI to extract the data from multiple data sources at the same time. So these 5 tables, we extracted them from SQL Server database. I'll go back to get data. This time I'm going to go into its drop down. Some common data sources are available here as well. And if I go to more, then again the same dialog box will appear. Now I have some more data which is there in some CSV files. So that is why I choose the connector for CSV files. Basically, which ones? So let me show it to you. I have two CSV files here. This seller format is one of them, and this reseller sales target. This is the second file. These are two CSV files from which I want to extract the data. So to extract the data from both of them, I choose the connector for text CSV, connect, and see this time the open dialog box appears in front of us. So as I was saying earlier, that the method to provide the location of the data might differ with different data connectors, with different types of connectors. So you can see it for yourself now. When we chose the SQL Server connector, SQL Server database connector, then a different dialog box appeared in front of us. And this time for CSV files, a different dialog box, that is the open dialog box, has appeared in front of us. Why the open dialog box? Because most of the times the CSV files and any other kind of files, they are either stored locally on our system or they are stored in some kind of shared drive only, which can be accessed to the directories of our system. So now let me, navigate to the files, go into that folder. Here is the color format file. Now I need to select both of them, but multi-select is not an option here. I am holding down the shift button right now, but still, let me show it to you. See, I'm holding down the shift button as you can see, but still both the files are not getting selected. Only one of them can be selected at a time. So I select color format here and I click on open. Now this time it will not ask me for, the authentication because this file is coming from the same system on which I'm using Power BI Desktop. So load transform data cancel. I'm going to load the data from it as it is. Now I hope you noticed one difference here. When we were extracting these 5 tables from SQL Server, and when we extracted the color format from the CSV file, there are two differences basically. The first one is that in case of CSV file, we were given the choice to only extract one table, and that is something which is very obvious because in CSV files, we can only store one table at a time. Okay. But the second thing was when we chose the connector for SQL Server, this one, at that time, we were given the choice to choose between the different connectivity modes, import and direct query. But when we choose the connector for CSV, then we were not given this choice to choose between import and direct query. Let me show it to you again. Get data, text CSV connector, the reseller sale target, and nowhere do we have that option to choose between the data connectivity modes. I select reseller sale target file, open it. See again, only one table we have the option here to extract it because in CSV files, only one table can be stored at a time. Again, we do not have the option to choose between the connectivity modes anywhere. We can only load or transform it. So we do that. But still, just like we saw it earlier, that in all the rest of the tables, the storage mode was what? Import mode, like in fact reseller sales. Similarly, for reseller sale target also, the storage mode is import, and for color format also, the storage mode is import. What do we understand from here? So from here, we understand that when we are extracting the data from different data sources, then we are given the choice to, choose the data connectivity mode in some of the connectors, whereas in others, we are not given that choice. And wherever we are not given a choice, like in text CSV, we are not given the choice to choose between the connectivity modes. In those places, the import mode is the one which is chosen by default and we cannot change it. Okay. So we can see here that the data from all of these tables is here in the table view or the data view. And all of these tables that we have extracted till now are in the import mode. But again, what is the difference between import mode and direct query mode? We have not discussed that till now. So let me do one thing. I'm going to save this particular Power BI file. I have created a folder for today's batch and I'm going to name this data connectivity. In this file, let me show you one more thing. If I go to the model view, can you see that between some of the tables, especially the ones which have been extracted from SQL Server, some relationships have been created. The tables are connected with each other via these relationships. Can you see this? So where did these relationships come from? We need to understand that as well. See, we never created these relationships. This is a property of Power BI that while extracting the data from the data source, If it sees that yes, in the data source, there are some relationships between the data tables, like they were here, then along with the data, it extracts those relationships as well between the tables and creates them. Okay, so these relationships are automatically created. If you need these automatic relationships, then that is fine. If you do not need them, then how can we switch it off? So we need to go to File, Options and Settings, Options. Okay, and see there are two types of options here in this dialog box: Global and Current File. And under both of them, we have the data load settings. We need to go to the data load under Current File. Okay, we go here, and in here, see there are two types of options which are checked. Import relationships from data sources on first load. This is what I was saying. That is, if the relationship is there in the data source, then along with the data, that relationship will be extracted as well. We switch it off if we do not want it. The other option is auto detect new relationships after data is loaded. So here Power BI, after the data is loaded, Power BI itself is going to scan all the tables that we have extracted, and it will see if between any two tables a relationship can be created or not. So what it will do is it will check it based on the column names. If the column names in two tables are the same, then Power BI will say that a relationship can be created between these two columns, and it will create that relationship automatically, even if it was not there in the data source. I'm going to switch off this option as well. But switching off that option now is not going to make any difference because the data is already loaded and the relationships are created. These two options need to be switched off before we actually load the data. Anyways, that's fine. Let me just save this file. I'm going to close this one. And we need to see the difference between import and direct query. So see, this is the folder in which I have saved this data connectivity import mode file. Let me open a new copy of Power BI desktop. And in this file, see what I'm going to do is I'm going to extract the data from the same data sources which we extracted earlier. The only difference will be that wherever we are given a choice, I will be extracting the data. Sorry, wherever we are given a choice, I will be using the uh, direct query mode instead of the import. All right. So let me open a blank report. Again, I will choose the connector for SQL Server. But before doing that, this time, let me go to again File, Options and Settings, Options, Data Load under Current File, and I will switch off these two options so that automatic relationships are not created. Now I will choose the connector for SQL Server, which is here. Some common connectors are given here also on the top. So again, the same server, localhost. Here I am given a choice to choose between import and direct query. So direct query is the one that I choose. I click OK. Now again, see, because I did not provide the database name there, I only provided the server name. So all of the inside the server, it connects to all of the databases again. But if I cancel it for a minute, and along with the server name localhost, if I provide the database name as well, Adventure Works DW 2020, here the spelling needs to be absolutely correct, the same one. Here, it has to be the exact correct name of the database. I choose direct query again. Because we are providing the specific database which we want to connect with, so that is why here we can see that it has connected to that single database only. It is also possible. Again, I will choose the factory seller sales table, all of its related tables except dim date and dim promotion. I'm going to load the same data as it is, but this time it is in direct query mode, correct? For these tables, we can see that the storage mode is direct query now. Now, I will go and choose the data from the CSV files, color format, open. Here we are not given a choice. In these two files, import mode only will be used, so we cannot do anything about it. As I said, wherever we are given a choice, we will use direct query. Where we are not given, we cannot do anything. So color format is loaded. CSV again, reseller sale target. Let me load it. Okay. Now let me save this one as well. And I'm going to call it data connectivity DQ mode, direct query mode. In the same folder, I have saved it. So both of the Power BI files are here. In both the files, we have extracted the exact same data, but if you look at them, the sizes of both the files are very much different, correct? The import mode file is 1077 KB in size, whereas the direct query mode is only 70 KB in size. Now, why is there such a big difference between these two files? So let me tell you about that. Okay, but before discussing this, I will show you one more thing. Okay, let us say that we are having an Excel file over here, currency data. Okay, now what I will do is I will copy this file and I'm going to paste the copy of the file in the same folder. So we have the currency data file now and we have its copy as well. So obviously in both the files, we will be having the exact same data, correct? But if I go to the currency data file, if I open it and I change some values here, like USD to INR conversion rate from 84.5, let's say I change it to 85.5 here now. I save it. The currency data file is saved. So the data in the original file, the currency data file has been updated. So does this mean that the same data will be updated in this copy file as well? Obviously not. See, if I open the copy file, it still will be having the previous data only, 84.5. Why? Because even though the copy file initially was created from the currency data file only, it was a copy of it. So initially both of them had the same data, but now the copy file is a standalone file. It has no connection whatsoever to the original file now. So if we make any changes to the currency data file, those changes will not reflect in the copy file because it is standalone. Something similar is going to happen in Power BI as well. So let me explain it. What is the difference between import mode and direct query mode? Okay. Why in the direct query mode, why the direct query mode file is having, a small size, whereas the import mode file is having a bigger size, even though in both of them we have the exact same data. So let us say that here we are having the data source in which the data is there, which we want to analyze. Okay. And this here is Power BI desktop. This is where we want to bring in the data for analysis. So we need to connect to the data source and we want to extract the data and bring it into Power BI desktop for analysis purposes. So connecting to the data source and extracting the data from it, it can be done in two ways. Either we can use the import connectivity mode or we can use the direct query connectivity mode. Now, in case of import mode, see what is going to happen. In case of the import mode, a local copy of data will be created here. The data from the source will be picked up as it is and a copy of it will be created here in Power BI desktop. Now, just like it was happening between those two files, that the copy was getting created, same thing will happen here. The data that is here, we will have the same data in Power BI desktop as well. But this copy of data will not have any connection with the data at the source now. At least not automatically, it will not have a connection. This means that if the data in the source is updated, then those updates are not reflected here automatically. Okay. If the data at the source is updated, then the data in Power BI desktop will not be updated automatically and we will not see the updated visuals automatically. Okay. But in case of, direct query, what is going to happen? A copy of data will not be created. Rather here only the metadata will be stored. Metadata is what? It is information about the data. Okay. Like which tables are extracted from the source. What are the names of those tables? From those tables, which columns are extracted? What are the names and data types of those columns? And this much information, not the real data inside them. And Power BI desktop in this case will be having a near real-time connection to the data source, which means that Power BI desktop will be reading the data from the data source only in near real time. And because Power BI will be reading the data from the data source in near real time, that is why if the data is updated here, then in that case, the updates are reflected here automatically. In near real time, automatically the data will be updated here. and our visuals will also be updated accordingly so that we can see the new and updated data. I hope this makes sense. Now see, because of this reason only, I'm in the direct query mode file right now. If we go to the table view, see, we can see the data of the color format table here. We can also see the data of the reseller sale target table here, because both of these tables are in the import mode and a local copy of these two tables is created here. So that is why the data of these tables we can see. But the other tables like dim employee, which is in direct query, dim product, dim reseller, dim sales territory, and factory seller sales, all of which are also in direct query, we cannot see the data of any of them here. And it is very clearly saying that we cannot show the data, this table, because it is not an import. See, what is the import mode? So in case of import mode, as I said earlier, a local copy of the data is stored in the PBIX file. The extension of Power BI desktop files is PBIX. Okay. So a local copy of the data is stored in the PBIX files in this case. And because of this, if the data the source gets updated, then those changes are not reflected in our Power BI files. Similarly, direct query mode, local copy is not stored, only the metadata is stored, and the Power BI file reads the data from the source in near real time. So if there are any changes to the data at the source, we can see those changes in the Power BI file as well automatically. Remember that I am using the term automatically here. Okay. So what is the difference between these two? We have understood that. But when to use import mode and when to use direct query? So because in case of import mode, a local copy of the data is getting stored in the Power BI file. Okay. A local copy of the data is getting stored in the Power BI file, because of which we can clearly see that the size of the file is bigger in this case with the same data. So we will only be able to use import mode when the size of data is small. Think about it. If the data goes up to a few hundred MBs also, then this Power BI desktop file, basically Power BI desktop is running on our laptops only, or our local systems only. Our laptops will not be able to handle such big files. And the processing time, the loading time of the data and everything in this file, basically the performance of this file is going to become low. Correct? The performance of this file will become low. So that is why when the size of data is small, only then we can use import mode. Or when the data in the file is not getting updated regularly. Okay, in these two cases only we can use the import. But if the size of the data is big, or if the data at the source is getting updated regularly, and we want those updates in our reports, in any of these cases, we have to use direct query mode. Okay, so when we're extracting the data from the source, then at that time, we can get some errors as well. So let us have a look at those errors very quickly, and then we are going to go ahead. So I have listed down some of the common errors over here. Okay, what are those? So first of all, we are having a query timeout error. Now I believe everyone understands what a timeout error is. That let us say that we want to extract the data from the source. Okay, in here we provide the source location, the credentials and everything. But let us say that the source is so busy in fulfilling all the other requests that it is not able to pick up our request, because of which it is taking a lot of time for it to pick up our request, execute it, and send back the required data to us. So in this case, our system Power BI is going to wait for a specific amount of time. For how long do we want it to wait? We can provide that in the advanced option, command timeout in minutes. It will wait for that much amount of time, but even if in that time, let's say we've provided 5 minutes, if in 5 minutes the data is not extracted from the source is not able to respond, then Power BI will return this error to us, that is query timeout. Okay. This means that the data source was not able to respond to Power BI's request for extracting the data. Then there is timeout expired. So we get this particular error when we have extracted more data from the source than we are allowed to. There is another error, could not find data formatted as a table. So this particular error, this particular error is specific to Excel files. When in Power BI, we choose the connector for Excel workbooks. See, here it is, Excel workbook, or in here also Excel workbook connector is here. When we choose the Excel workbook connector, so at that time, Power BI assumes that here, basically what's going to happen in the Excel workbook from which you want to extract the data will be formatted in the form of a table. But if the data is not formatted in a form of a table, then it will return this particular error, could not find data formatted as a table. Could not find file, I believe everyone can understand this one, that either we have provided the wrong file name, or we have provided the wrong path, or the file has been moved from that particular location that we provided, or maybe the file is deleted, or something like that has happened. Then obviously we are going to get this particular error. There is an error called data type error. So what happens is when we load the data, then at that time Power BI tries to determine the data type of every single column here and every single value. It tries to determine the data type of every single column and every single value there. If it is not able to determine what is the data type of any of the columns or the value, then it is going to return this data type error. And in case of data type error, that particular column or the value can be returned as a blank value. Even though there is some data there, but it will be returned as blank. And then there is this error. There was an error in loading the data due to an error in a previous table. So what does this mean? So if we get an error in loading any of the tables, like they were trying to load some tables here, and in the companies table, they got a timeout expired error. Then all the other tables which are getting loaded along with it, they are going to return this error. Load was cancelled by an error in loading a previous table. Okay. All the other tables will start returning this error, and none of the tables will be loaded to Power BI. See, I hope all of you remember that before we loaded this data in the direct query mode file, we had gone to options and settings, options, and here we went to data load of the current file, and we switched off these two options for relationships. Now, because we switched off these two options for creating automatic relationships, that is why in the data model we can see that there are no relationships between any of the tables now. It is not because of direct query mode, it is because we switched off that option. Okay. All right. So in here again, I'm going to extract the same data from SQL Server, localhost, connectivity mode I will use import only. I'm not going to change that. And I'm going to extract the same data. Okay, factory seller sales, where is it? Yeah, the related tables except dim date and dim promotion. And this time, see, instead of going to the load option, I will go to the transform data option here. And as soon as we go to the transform data option, you can see that a separate window has opened in front of us. We have Power BI desktop here, but in Power BI desktop, you can see that no data has been loaded here yet. Correct? There is no data here yet. These tables have opened in this window, Power Query Editor. And here these tables are known as queries, as we can see on the left hand side of the screen. Now in here, we can also get the data from the other files like text CSV. Let me go there. Files, color format, and OK. And text CSV, reseller sale target, and OK. Okay. So we have all of these 7 tables or queries in here. Now for all of these tables and for all the columns of these tables, can you all see that we are having, a few metrics here. In Power Query Editor over here, for every table and every column, what we have is we are having, these graphs over here, and we are having some metrics, valid, error, empty, percentages, and all that. Now, what is this all about? So remember, how did we come here to Power Query Editor? So in Power BI Desktop, when we were extracting the data from the source, at that time we provided the source. Okay. And after selecting our tables, whatever tables we want to extract the data from, we clicked on transform data. Okay. So then this Power Query Editor window opened. So what is this Power Query Editor? It is actually an inbuilt tool. Okay. It is an inbuilt tool available in Power BI Desktop for cleaning and transforming the data. Okay. It is an inbuilt tool available in Power BI Desktop for cleaning and transforming the data. Okay. And if you want to clean and transform the data, then obviously for that, what do we need? For that, we need, to know the metrics about it. We need to understand our data and all that. Only then we will be able to clean and transform it. Okay. So these graphs and all of these percentages, these are basically giving us the different types of metrics. Okay. They are giving us the different types of metrics that are there. All right. Now let me show you what they are. So first of all, I'm going to switch off them and I'm going to show them to you one by one. So I go to the view menu on the top. I hope all of you can see it. And in the view menu, I have these three options, which are, column quality, column distribution, and column profile. Okay. So I'm going to switch them off. I switch on column quality first of all. And as a result, see, I'm getting the percentages of valid, error, and empty here. What does this mean? So it basically is telling us that in any particular column, how many valid values are there. Okay, what percentage of valid values are there? That is, in this column, how many values or what percentage of values have been loaded correctly without any kind of error. Then there is the empty percentage as well, which is 0% right now for this column sale order number. Okay, and this error is basically giving us that in how many rows of this particular column we were getting an error while loading it. Okay, and what is empty? Empty means that in what percentage of rows for this particular column there were empty or null or blank values. That is what we get from here. These are the percentages. If I hover my mouse over it, then along with the percentages, we also get the numbers here. Correct? So here it is saying that 100% of the rows in this column sale order number, that is all the 1000 rows, are having valid values in them. That is, they are loaded correctly. Neither they are having any errors nor they have blank values in them. 0 rows or 0% rows are throwing any errors, and 0 rows or 0% rows have empty, blank, or null values in them. Okay. So this basically gives us an idea about the health of our column. Okay. And see, when we switched off these options, column quality, column distribution, and column profile, then they're switched off for all the columns of all the tables. And when we switch them on, like a switch on column column quality, it is getting switched on for again all columns of all the tables. Using this, we can quickly, skim through our data or scroll through our data and check the health status of our columns. If we are getting any errors in them, or if there are any kind of, empty values in the columns. Because if in our columns we have some empty values, then those empty values need to be handled. Either we need to remove those empty values, or most of the times we need to impute those empty values with some other value, either with the mean, mode, or median, depending on what kind of data is there, or with some other value. Correct? I hope that is clear. Then after that, if I switch on column distribution, then even these graphs appear here for again all columns of all the tables. Now, what are these graphs all about? We are going to talk about it in a minute. But before that, see, for every column, we start getting this number of distinct and unique values here as well. We start getting this distinct and unique as well, number of distinct and unique values. Now, it is telling us, if I look at the sale order number column only, it is telling us that in this column, there are 102 distinct values and there are 13 unique values. Okay. Now, what is the difference between distinct and unique? We need to know that now. Okay. So I'm going to, explain this very quickly. I'm going to explain this very quickly over here. So let me open an Excel file. Okay. And in here, we are going to take an example. Let us say that there is a college or a school. Okay. And in there, the teacher has taken a test of, the students of a class. Okay. The test was out of, let us say, 20 marks. And this is what the students have scored. Out of 20, like this. These are the, test scores of the students which have been recorded. Okay. These are the test scores of the students. So how many values do we have in total here? So in this test scores column, we are having a total of 15 values. Okay. You can see that here as well. Count is 15. Now, out of these 15 values, we want to find out how many distinct values are there. Distinct means different types of values. So see, one type here is 15. The other type is 12. Next type is 20. Next we have 19. Then we have 14. The next type is 18. We have 5 after that. Then there is 16. Then the next type 15. This type 15 we have already listed it down here. So no need to list it again because we are looking at different types of values. After that we have 18, which we have again already listed down. Then 19 is also already there. 20 is also already there here. Okay, then next type 11, not listed down yet. Then we have 13, again not listed down already. Then after that we have 10. It is a new value. So these are the different types of values that we have here. So how many total distinct values do we have here? We have 11 of them. Correct? And now we need to find out how many unique values are there. Unique, I believe everyone knows that these are those values. Unique are those values which are going to appear only one time in the data. So using conditional formatting here, we can find them out. So the values which are in white, that is 12, 14, 5, 16, 11, 13, and 10. These are the values which are unique. And how many of them do we have here? 7. Okay, so total unique values, we have 7 of them. Now, if you look at this carefully, then all of the unique values are distinct. But not all distinct values are unique. So what does this mean? That in the test scores column, we have a total of 15 values. In these total 15 values, there are 11 distinct values, 11 different types of values. Out of these 11 different types of values, 7 values are unique. It means that 7 types of values out of these 11 types, 7 types of values are appearing only one single time. The rest of the 4 values that are there, they are repeating among themselves. How many times they're getting repeated, we have no idea of that right now. Actually, we do if we work on this data, but we have not counted it. But anyways, rest of the 4 values out of these 11 distinct values, they are repeating among themselves. Correct? The same thing, we have it here as well. So in the sale order number column also, we have the same thing. So it is saying that in here, in this column, we have 102 distinct values. That is 102 different types of values are there. Out of which 13 types of values are unique. That is, they're appearing only one time. The rest of the 89 values, how 89? 102 minus 13. The rest of the 89 values are repeating among themselves. How many times each value is getting repeated? We have no idea of that. One value can be repeating 2 times also, 10 times also, 100 times also. We do not know that right now. Now, what are these graphs all about? So these graphs are basically frequency distribution graph that we used to study about in our school days. Okay, so these are the frequency distribution graphs, and they're arranged in the descending order of frequency. Okay, like if I talk about this order date column, so from here we can see that there is some value in this order date column which is having the highest frequency, that it is repeating the most number of times, or it is appearing the most number of times in this column. Then there is another value which is appearing the second highest number of times, or it is repeating the second highest number of times in the order date column, almost the same as the column with the highest frequency. The value with the third highest frequency is there, but its frequency is almost half of the first 2 values. Correct? This is what we can see from here. But again, in here, do we have any idea which is this value which is appearing the highest number of times, the second highest number of times, and the third highest number of times? Are we getting any idea like that from here, that which are these values? No, we are not. Similarly, what are their frequencies? Are we getting any idea about that? That the value with the highest frequency, is it frequency, let us say 10, or is it 100, or it is 1000, or what? We are not getting any idea about that either. So what is the use of it? What is the use of getting this frequency distribution graph over here if neither it is telling us about, which values are there, nor it is telling about what frequencies are there? In here, see, the benefit here is that we can quickly, go over our data here, and in here, with the help of this graph, we can quickly, look for sudden changes in the frequency. Like, let me show you an example of this one. There is one example of that in this data set. The dim reseller table. In the dim reseller table, check the business type column. In this column, it says that there are 4 distinct values, out of which 0 are unique. None of them are unique. Which means that in this particular column, there are 4 different types of values, and all 4 of them are repeating. Correct? But if you look at this particular graph, you will see that out of the 4 values, 3 values are having very high frequency. Almost equal. It is almost equal for all 3 of them. But the 4th value suddenly is having negligible frequency as compared to the first 3. This is a sudden change in the frequency distribution over here, correct? So can we, say here that this 4th value, whatever it is, its frequency is, suddenly changing, or this value is kind of an outlier in the data set here. Now, which value it is, what is its, frequency and all that, we don't get any information about that right now. But if while this column is selected, we switch on column profile, then see whatever column is selected while column profile is switched on, for that column, we get to see that value distribution, the frequency distribution in detail, along with some other column statistics. So here we get to know that these 4 values are value-added reseller, whose frequency, if we hover over its bar over here, is 238. Then the next value is specialty bike shop, whose frequency is 231. Warehouse, whose frequency is 227. And then there is wear space house, whose frequency is only 5. So we can very clearly see from here that there are 2 values, warehouse and wear space house. And wear space house is obviously a typing error. So what do we get from here? We looked at this particular column. Sorry, we looked at this particular graph over here. From here, we find out that yes, there is a sudden change in the frequency of one of the values. This sudden change in frequency might mean that there is an error. Not necessarily, but it might mean that there is an error. When we check this column, yes, we found out that yes, there was an error in this column. But it is not necessary. Okay. In case there is an error, now we need to correct it. So I right click on this column, replace values, and I'm going to replace where space house, these values with warehouse. Press enter. And you can see only 3 distinct values or 3 types of values remained here. All of the where space houses have been converted and merged with warehouse. So warehouse earlier, which was having a frequency of 227, now its frequency is 232 because the 5 where space house values are also converted to and merged with this one. In here, for the sale order number column, when we were, having this column quality, so here it was telling us that all 1000 rows or 100% of the rows in here in this column have valid values. What does this mean? It means that in this particular table, the factory seller sales table, there are 1000 values, correct? And when we switch on column profile, for any of the column, we select any column. For all of them, we will see here that the count of values in the column is 1000. Here also it is telling us that the column count of rows here in this particular table is 1000. But if you want to get, the exact count, then we can look at the bottom left corner here. Here it is telling us that in this table, we have 21 columns and 999 plus rows. 999 plus generally means that there are more than 1000 rows here in this table. Then why is everything showing us that there are only 1000 rows? It is because of this particular option that we have here, which is activated by default. Column profiling based on top 1000 rows. This option, let me just zoom into it, column profiling based on top 1000 rows. This option means that by default, all of the statistics that will be shown to us here, they will be based on the top 1000 rows of the table only, no matter how many rows there are in the table. If you want these statistics and everything for all the rows of the table, then just click on this column profiling based on top 1000 rows. The second option that appears, column profiling based on entire data set, select it. Okay. And in here, we can see that the statistics have been updated. Like for the sale order number column, where earlier it was showing 102 distinct and 13 unique. Now it is showing 3616 distinct and 564 unique values. And now in this column, it is telling us that there are 57,851 rows in the table. So in this table, actually there are 57,851 rows, not 1000. So that's it from this lecture, and we will see you in next lecture. Thank you so much.